Welcome to David Alexander Maths Tuition. This is chapter 6D on trigonometric identities. So we should all by now hopefully be very familiar with the sine squared plus cos squared equals 1. Now if we were to divide this whole equation by sine squared x, what we would have is, well, sine squared divided by sine squared is 1. Cos divided by sine is cot. So cos squared divided by sine squared is cot squared x, and 1 divided by sine squared is cosec squared x. So here we have a new trig identity. Cosec squared x is the same as 1 plus cot squared x, and we can also say that cot squared x, we can rearrange that as cosec squared x take away 1. Now we can do a similar thing if we divide through by cos squared x. Sine squared divided by cos squared is tan squared x. Cos squared x divided by cos squared x is 1, and 1 divided by cos squared x is sec squared x. So this is our other identity. So we've got 1 plus cot squared is cosec squared, and tan squared plus 1 is sec squared. And we can also rearrange this so that we have tan squared is sec squared x take away 1. So always bear in mind, hopefully you'll get into the stage where you know that sine squared plus cos squared equals 1, but also bear in mind these other two trig identities. Tan squared plus 1 is sec squared, 1 plus cot squared is cosec squared. Now I wouldn't say it's crucial to remember these. I sometimes may forget what they are. I'm never sure, is it tan squared equals sec squared x plus 1 or minus 1? So I write out sine squared plus cos squared is 1, and then think, okay, divide through by sine squared or divide through by cos squared, just so that I make sure I'm getting these new trig identities correct. Okay, so for these three questions, we need to simplify the following expressions. Well, the first one has got a tan squared in. Let's ignore the fact that it's a 4 theta. Imagine that was just a theta or an x. So let's just think about our trig identities. We've got sine squared plus cos squared equals 1. So what's the one with tan squared in? Well, that's the one where I divide all through by cos squared. So that will be tan squared plus 1 equals, what did I say I was dividing through by cos squared? So 1 divided by cos squared is sec squared. Okay, so 3 plus 3 tan squared is the same as, well, 3 lots of tan squared plus 1. So that's going to be 3 sec squared x. 3 lots of tan squared plus 1 is 3 tan squared x plus 3, which is what we've got. The only difference is it's a 4 theta instead of an x, but that's fine. That's just simply 3 sec squared 4 theta. For the second one, I'm not really sure what to do here, but I'll expand the brackets. That might enlighten me. So that's going to be cosec squared x take away 1. Now, if I think back to my sine squared plus cos squared equals 1, let me just write it over here again. I often just write it as s squared plus c squared equals 1. So for this one, I divided through by cos squared. So here, if I divide through by sine squared, that'll be a 1. That'll be a cot squared, and 1 divided by sine squared, that is cosec squared. So cosec 1 plus cot squared is cosec squared. So cot squared is going to be my cosec squared take away 1, cosec squared take away 1. So I can just simply write that as cot squared x. Done. Okay, so for this last one, 1 minus cos squared, I know that sine squared plus cos squared is 1. So 1 take away cos squared is sine squared. So what I have is sine squared theta over cos squared theta, and of course sine divided by cos is tan, so that is simply tan squared theta, and we're done there. Okay, so here are some more to be simplified. So for the first one, what am I going to do here? I'm actually I've spotted straight away that 1 minus cos squared, that is sine squared x. So what I have here is cosec squared theta multiplied by sine squared theta. Now cosec squared is 1 over sine squared. So what I have here is sine squared theta, which is that one there, and cosec squared as a numerator will become sine squared theta as a denominator, and of course anything divided by itself is 1. So all of this stuff here, that just simply equals 1. Okay, so sec squared x. So I know that sine squared plus cos squared equals 1. So there was one with, what's the one with tan squared? I believe the tan squared one was linked to the sec squared one anyway. And so to do that, I'm going to be dividing through by a cos squared. Sine squared divided by cos squared is tan squared. Cos squared divided by cos squared is 1. And 1 divided by cos squared is sec squared x. Okay, so I've got a sec squared x, so I can replace that with a tan squared x. So what I have is tan squared x plus 1 minus tan squared x, all to the power of 5. I could have replaced the tan squared x with the sec squared x, take away 1. It would all result in exactly the same thing at the end. Of course, tan squared take away tan squared is 0, so all we're left with is 1 to the power of 5, which is of course 1. So both of these expressions can be simplified to just 1. Okay, 2 more here. Again, I'm going to play around with the sec squared x. So sine squared plus cos squared equals 1. For the tan squared, I'm dividing through by cos squared, so that is tan squared x plus 1 equals sec squared x. So that will be 3. Take away tan squared x plus a tan squared x plus 1, and the tan squareds will cancel. 3 plus 1 is 4. Okay, so I can already use the 1 plus tan squared x. I've already got that over there. So what I have here is tan theta sec theta over sec squared theta. So I can see straight away I've got a sec on the top and a sec on the bottom. So that is just going to be tan theta over sec theta. Now I'm going to rewrite sec theta. Sec theta as a denominator becomes a cos theta as a numerator. So that is tan theta cos theta. And of course tan, that can be written as sine theta over cos theta. And that other cos theta will be a numerator there. And they can both cancel. So all of that will simply simplify down to sine theta. Okay, so for this question, we've been told that the cot theta is something, and from that we want to work out what sine of theta and the cos of theta are. Now, we would have done something fairly similar, I think maybe in the year 12 unit, when you'd have probably been told that the tan of theta equals a certain value, not the cot of theta. But it's quite an easy fix, this. If the cot of theta is negative root 7, that means it's negative root 7 over 1. So therefore, the tan of theta is that flipped, so that's going to be minus 1 over the square root of 7. Now we know that the tan of an angle is the opposite over the adjacent. So if this is my theta, then the opposite is going to be 1 and the adjacent is root 7. I'm not going to mark them, either of them, as negative because it doesn't make sense to make the side of a triangle negative. I'm just going to ignore that for now. Okay, so therefore I can work out the hypotenuse, which is root 7, the square root of root 7 squared plus 1 squared, which is root 8, or 2 root 2. So if the tan of theta is negative 1 over root 7, then we can say that the sine of theta, that's the opposite over the hypotenuse, that is 1 over 2 root 2, or it could be negative 1 over 2 root 2. We'll investigate the signs in a second. And the cos of theta is root 7 over 2 root 2. Again, it could be negative root 7 over 2 root 2. Now we know that theta is between 270 and 360. So CAST, there's my cast diagram. So it's in this quadrant here. Now in this quadrant, cos is the only one that is positive. Sine and tan are negative, and we can see that tan is negative. Well, tan is just negative root 7 flipped, still negative though. So cos is positive, so the cos of theta is positive root 7 over 2 root 2, but sine is also negative in this quadrant, so actually it will be negative 1 over 2 root 2, and we are done there. Okay, so another fairly similar one. We know that the tan of theta is 7 over 24, so 7 over 24, and therefore the hypotenuse is 25. So if the tan of theta is 7 over 24, then cos theta will be 24 over 25, and the sine of theta will be 7 over 25. I just need to investigate whether they're positive or negative. CAST, 180 to 270 is this quadrant here. So tan is positive, okay, that's why it's positive 7 over 24, not negative 7 over 24. So if tan is positive, then cos and sine are both negative. So if the cos of theta is negative 24 over 25, then sec theta is going to be negative 25 over 24. And if the sine of theta is that, then the cosec of theta is going to be negative 25 over 7. Oh, and of course, we needed cos theta as well. So cosec theta down here, sec theta done, and don't know why cos theta is specifically needed, but it is. There we go, done. Okay, prove the following identity. So we can play around with either side, but I'm going to play around with the left-hand side because I know that I can do something with sec squared. I vaguely remember some identity with sec squared, so if I can't remember it, I'll just write out sine squared plus cos squared equals 1, and for the sec squared one is the one where I divide through by the cos squared. I mean, if you don't know it's the one where you divide through by cos squared, try dividing through by sine squared and cos squared, see which one you prefer when you do that. So if I'm dividing through by cos squared, I'm going to get tan squared x plus 1 equals sec squared x. Perfect. So sec squared x is tan squared x plus 1. So what I have is cosec A tan squared A plus 1. So if I'll expand those brackets, that will be cosec A tan squared A plus cosec A. So I've got the cosec A, so I just somehow need to show that cosec A tan squared A is tan A sec A. Now tan squared, that is sine squared A over cos squared A, and cosec A will be my numerator, but I'm just thinking, well, how else can I write cosec A? Well, cosec as a numerator, that is a sine A as a denominator. So what have I got here? I'll just write in the cosec A part as well. So sine squared over sine, well, there's a sine A that can cancel top and bottom. So that will leave me with sine A over cos squared A. Let me just rewrite what we've got. So I've got sine A over cos squared A. And cos squared A is a cos A times a cos A. And there's my plus cosec A. Now, sine divided by cos is tan. So what I have there is tan A over cos A plus cosec A, and cos as a denominator is sec as a numerator. So that is tan A sec A plus cosec A, which is what we want to do. Of course, we can always just write it again as cosec A plus tan A sec A, just to be on the safe side. Okay, so here's another proof. I am going to mess around with the left-hand side because there's a bit more going on, and I know that I can do something with the tan squared. Sine squared plus cos squared equals 1. So if I divide through by my cos squared, that will give me tan squared plus 1 equals sec squared x. So first of all, does this help? 1 take away tan squared doesn't really help massively, but 1 plus tan squared is sec squared x. So what I have is 1 minus tan squared A over sec squared A there. So I need to do something with the tan squared, or do I? Maybe I can. I'm not 100% sure this will lead to where it needs to go, but that's often the case with these. Just try something and you never know what's going to happen. So 1 over sec squared A, take away tan squared A over sec squared A. So I'm just separating. Now 1 over sec squared, sec as a denominator, that is the same as cos as a numerator. So I've got cos squared A there. Take away, now tan squared is sine squared over cos squared. I've got the sec squared as a denominator, which I can move upstairs to be a numerator of cos squared A. Well, that's quite handy. I've got a cos squared and a cos squared. And okay, so I've got cos squared A take away sine squared A. Now I know that cos squared A, I need to get rid of a cos squared A because there's no cos squared A. And the only way I can get rid of a cos squared A is by turning it into 1 minus sine squared A. So sine squared plus cos squared is 1. So 1 take away sine squared is cos squared. So I've got 1 minus sine squared A minus that other sine squared A. And that is, of course, 1 minus the 2 sine squared A. There we go. Perfect. So separating this fraction into 2 separate fractions was the way forward. Okay, so with a question like this, there's a lot going on and you probably don't know where to start, but you've got an equation with a tan squared and a sec squared, which is not great. So probably a good idea is to get it all in terms of tan squared or sec squared. It doesn't really matter. Now, I know that sine squared plus cos squared equals 1. So if I divide through by cos squared, I get my tan squared x plus 1 equals sec squared x. So let's just play around. So I want sec A. So maybe it would make sense to turn the tan squareds into sec squareds. So therefore tan squared x, that is sec squared x take away 1. So 5 tan squared is going to be 5 sec squared A minus 5 plus 7 sec squared A equals 11. So what we have in total is 12 sec squared A take 5 equals 11. So therefore 12 sec squared A is 11 plus 5, which is 16. So sec squared A is 16 over 12, or sec squared A is 8 over 6, or 4 over 3. So therefore if sec squared A is 4 over 3, then the sec of A is either plus or minus the square root of 4 thirds. Now, is it plus or is it minus? We know that A is obtuse. So C-A-S-T. So if it's obtuse, it must be between 90 and 180 degrees. So sine is the only one that is positive. So cos would be negative. So if cos is negative, then sec is also negative. So the sec of A would be minus, we can actually, the square root of 4 over 3 is root 4 over root 3. So 2 over root 3 might be a better way of writing that, or 2 root 3 over 3, but it's definitely negative in this case. Okay, so here we need to solve a couple of equations. So I've got my first equation in terms of tan theta and sec squared. So what I'm going to do is I'm going to turn the sec squareds into tan squareds, and then I'll end up with a quadratic equation with a tan squared, a tan, and maybe a number hanging out the back. So I've got my sine squared plus cos squared equals 1. This is the one I'm going to divide through by cos squared. So tan squared plus 1 is sec squared. Okay, so 3 sec squared, that is going to be, let me just write this down here. So 10 tan theta is going to be 3 sec squared, which is 3 tan squared theta plus 3. I'm going to make that equal 0. So 3 tan squared theta, theta, take away 10 tan theta plus 3 equals 0. So using my quadratic equation solver, I'm going to get that the tan of theta is 3 and that the tan of theta is 1/3. Okay, so therefore theta is, so here I'm dealing in degrees, so I'm just going to make sure that I am actually in degrees on my calculator. So inverse tan of 3 is 71.57, and I'll add 180 degrees to that. Remember that tan repeats every 180, so that's 251.57 degrees. And if I add another 180, that would definitely take me above 360. Now, from my tan of theta equals 1/3, so the inverse tan of 1/3 is 18.43 degrees. And if I add 180 to that, here's my other solution of 198.43 degrees. So 4 solutions in total there. Looking at the next one, again, we know sine squared plus cos squared equals 1, and tan squared plus 1 equals sec squared. So what I'm going to do is I'm going to turn the tan squareds into sec squared. So tan squared is sec squared minus 1. So what we have is 3 sec theta equals 2 sec squared theta, take away 2, and minus 2 plus 3 is plus 1. So therefore, turning it into a quadratic, I've got 2 sec squared theta, take away 3 sec theta plus 1 equals 0. So therefore, the sec of theta is 1, and the sec of theta is 1/2. So therefore, when I'm going to solve it, I can turn it into cos of theta is 1, and the cos of theta is, well, this fraction flipped, cos of theta 2. Well, the cos of theta can never be 2. So it's just where the cos of theta equals 1. Now, actually, I'm just going to use my, just rather than using my calculator, when do I get, so let me just work out, so this is 2 pi here, this is negative 2 pi, so pi is this point here, and this is positive pi. So when am I getting this solution of 1? Only on this one place here, and that is when theta is 0. There we go. So theta is 0 degrees. That's the only solution to that equation there. Okay, so here are two more slightly nasty equations to be solved. Here I know that cosec squared, I can turn that into a cot squared. So sine squared plus cos squared equals 1. Here I'm dividing through by sine squared, so 1 plus cot squared equals cosec squared. So I've got 7 cosec squared, so that can be replaced with 7 plus 7 cot squared. So I've got 5 cot theta plus 7 plus 7 cot squared theta equals 7. Take away 7 from both sides. I've now made it equal 0. So what I have is 7 cot squared theta plus 5 cot theta equals 0. So what I can say here is that cot, I can turn that into cot theta, and then 7 cot theta plus 5 equals 0. So therefore cot theta equals 0, and cot theta is negative 5 over 7. So therefore the tan of theta is 0, and the tan of theta is negative 7 over 5. Sorry, that was an equal sign there. Right, so tan of theta equals 0. I might not actually need the calculator for this one anyway, but for the tan theta equals 0, but I'll use it anyway. Inverse tan of 0 is, of course, 0. So therefore theta is 0. So remember, tan repeats every 180 degrees or every pi radians. So that'll be 0, pi. It can equal 2 pi. And it can also be negative pi and negative 2 pi as well. Let's investigate the tan of theta equals negative 7/5. So minus 7 over 5, shift tan answer. I am getting that theta is minus 54.46. If I take away, what am I doing? I'm in degrees, of course. That's idiotic of me. So this is the sort of thing that can happen quite a lot. So let's do it into radians. Minus 7 over 5, inverse tan answer is, there we go, that's a bit more like it. So I've got minus 0.95. I'm going to subtract pi from that. So the one before that is going to be minus 4.09. The one before that will be minus 409 minus another pi, but that will be definitely beneath negative 2 pi. So now I'm just adding pi to the minus 0.95, and what do I get? I get 2.19, and if I add another pi to that, I will get 5.33, and if I add another pi, that will definitely put me above the 2 pi there. So I get 1, 2, 3, 4, 5 solutions from the tan of theta is 0, and 4 solutions from the tan of theta is negative 7/5. Okay, so this second one is a bit of a problem. Well, it's difficult. So what I'm going to do first of all is expand the bracket. So what I'm going to get is sec squared theta minus 6 cos theta sec theta plus 9 cos squared theta equals 5 tan theta minus 9 sine squared theta. Now this one seems a bit impossible because we've just got too many different bits of trig going on, but there's a couple of things that are worth looking at. So first of all, cos theta sec theta. Sec theta is 1 over cos theta. So cos theta sec theta is cos theta over cos theta. In other words, just 1. So the cos theta sec theta, they just cancel each other out. So that's just minus 6. Now another thing that I've just spotted is, what if I move the negative 9 sine squared theta over to the other side? So 9 cos squared theta, that's going to be plus 9 sine squared theta is 5 tan theta. Well, sine squared theta plus cos squared theta is 1. So 9 cos squared theta plus 9 sine squared theta is 9. So this is going to be sec squared theta, take away 6 plus 9, in other words plus 3, is 5 tan theta. And I know that sec squared, this is the one, I'm starting to memorize them now, so tan squared plus 1 is sec squared theta. So sec squared theta is tan squared theta plus 1. So tan squared theta plus 1 plus 3, in other words plus 4, is 5 tan theta, make it equal 0. So tan squared theta, take away 5 tan theta, plus 4 equals 0. So let's solve it. So quadratic equation solver on the calculator. 1x squared minus 5x plus 4. I'm getting that the tan of theta is 4 and 1. Okay, so therefore theta is the inverse tan of 4. Just checking I'm in radians. Inverse tan of 4, I'm getting 1.32. If I add pi onto that, that will definitely be greater than pi because this is positive. But if I take away pi for the previous solution, I'm going to get minus 1.82. And from the tan of theta equaling 1, so shift tan 1, I'm getting pi over 4. Again, if I add pi to pi over 4, that will be above pi. But if I subtract pi from that, I don't know why I need my calculator, that's going to be minus 3 pi over 4. There we go. So 4 solutions in total. Bit of a tricky one, that one, but a few things to watch out for. Cos, sec, they just cancel. And also spotting for the sine squared plus cos squared equaling 1. Very useful as well. Okay, here's one final question, and we need to somehow get from this rather nasty looking equation that equals x into some equally disgusting looking stuff. Now, what I'm going to do first of all is we know that there's a link between sec squared and tan squared. So sine squared plus cos squared equals 1. So tan squared plus 1 is sec squared. So sec squared is tan squared plus 1. So this is 6 tan squared theta plus 6 minus 3 tan squared theta equals x. So therefore 3 tan squared theta plus 6 equals x. So I'm going to take away 6 from both sides and divide through by 3. So what I have is tan squared theta is x. Let me just write that again a bit more neatly. So tan squared theta is x, take away 6 over 3. Now I need a cosec squared. Now how do I go from tan squared to cosec squared? Well, the answer is via cot squared. If tan squared is this stuff here, then cot squared theta is going to be 3 over x take away 6. And I know that if sine squared plus cos squared is 1, then what I can say is that, let's just divide through by sine, so 1 plus cot squared equals cosec squared. So cot squared is cosec squared take away 1. So what I have is cosec squared theta take away 1 equals 3 over x take away 6. So I'm just going to add 1 to both sides. And now I can just do my crisscross smiley face. So therefore the cosec squared theta is going to be 3 plus x take away 6 over x take away 6. And that is it's going to be negative 3 plus x, so x take away 3 over x minus 6, and that is what we were aiming for all along. So again, one of those horrible questions, you've got no idea how, there's no, well, unless you're extremely good at maths and you can see a clear path, a lot of it is just trying some stuff and see what happens until you hit the desired target.